So how many elements are there? That many times you have to iterate over the array, right? To check whether the key is present or not. Then what you will do if list of I is equal to key, correct? So what you will do if the list of I is equal to key, you will print that particular index. You'll print that particular index and break from the loop, correct? So you have to break from the loop because the key is already found. Suppose once the iteration is over, this else will be executed. Else block you can have key not found. So this is my size of the array and these are the number of elements. So next I have to enter the key that I'm looking for. So suppose I'm entering 4. So what is the, or you can customize here, index of the key. Right. So the key is found at the position 2, right? Starting from 0, 0, 1, 2. So if at all you want to print from the first index, you can just make it as I plus 1 so that key will be presented in the starting from the 1, right? So 1, 2, 3. So 3 is the key that we are looking for. And the index position is starting from the first index. So output will be 3. So this is the basic linear search that you have done already. What if the key is not found? For example, I'll take 4 elements. And if I'm trying to look for 6, so key not found. So in Python, as I told you, you can combine for with else, right? So this else will execute only when all the iterations are over. So if the key is found inside the list, we are breaking the loop, right? So this else will not execute if you in between terminate the loop. This will else will work only when all the iterations are successfully completed. So we can use this else block, or else you can have some other flag variable, or like here only you can check. So any other method you can use, but this is the most like easiest one which you can implement. Okay, so I'll give one more alternative version of this particular linear search which you can try later on. So you can make a note of it. I won't explain, but you can uh, try it later. So linear search, find the index of last occurrence of, right. So this is the alternative version which I'm giving. So here you are trying to go from the starting from 0th index and you are iterating one by one, and whenever key is found, you are just printing the index and breaking the loop, right? So in this case, what I want you guys to do is suppose, say for example, this is my array and my key is 4, right? Suppose my key is 4 and this is my array, right? So what I want is generally if you go from the normal order, so your index will be 1, 2, 3, 4, right? So even index will also be written as 4. But in this case, we want to return the index as 6, right? So what is the modification you can do for this? So for in this case, the index should be written as 6 because we are looking for the index of last occurrence of the key. not the first occurrence. So 4 is appearing in the end, right? So whose index position is 1, 2, 3, 4, 5, 6, right? So we want to print 6 as the output, where the key is appearing in the end, right? So what is the modification you can do to this code? You can think, yeah. So yeah, Vinay has written iterate in reverse. Correct. So you can start from n, or like if you're considering from zeroth index means you have to start from n minus 1. So n minus 1 you can start and go up to -1, or you can start from n, go up to 0. Any one thing is fine. So you can just modify the for loop to get the index of last occurrence. So others can also try this approach, right? So you can take this as homework and do it. Right. So try to implement this. Okay. So this is a basic searching that I have taught you. Linear search with the last occurrence of the key. You can, because in Python it will be very easy. We have range function, right? So you just need to traverse from the backend and look for the key, right? So that is the linear search. Very simple. Most of the questions you have done it, and most of the applications are based on the linear search only. Okay, so next one we have is binary search. Correct. So binary search, obviously, what is the condition for binary search? How does the binary search algorithm works? Before sorting, what is the condition? The array should be sorted, correct? So that is the first condition. So the reason being, what is the reason we are considering the sorted? It is based on the assumption that all the elements towards left of the mid are less than mid, and right side are right. So this is the main logic, right? So you will be dividing the index starting from 0 to n. Then you will find the mid index, and all the elements that are towards left side are, you know, less than the mid element, and all the elements towards the right side are greater than the mid element. So that is the main fundamental logic behind binary search. So this is a like same approach, but the only thing is this will be more optimized because you are not going to search all the elements starting from 0th index. It will minimize your number of iterations, correct? And time complexity will also be, further reduced based on the binary search, correct? So can you guys tell me, like, let's implement it is using a function where, like, generally most of the platform, as I told you, they'll give you the function only. So in the last class, I told you, if they mention something like this, okay. So, and assume that it accepts an array element, array as the list, and key as the value, correct? And if they say, if they are written something like this, what does it mean? The function will accept an array list and a key, and it will return always integer value, correct? It can be any integer value, right? Negative or positive, but this arrow mark indicates the integer value. So you need to implement this function. So as of now, let's keep it as it is. Then remaining part will be same as the linear search. So here will be same as the linear search, right? You require size of the array. You need to enter the values, and key is required. Then what you will do, you will call that function, binary search function, binary underscore search. And what you need to pass to it, the list one as well as the key. So these two values you have to pass to the binary search, and this it will take it and further process the searching operation. Then later on we'll see based on the return value we'll take some action. Right. So this is the main logic. Now what is the first thing that you have to do in binary search? Tell me, because you already learned, you should tell me. Two variables are required, right? You can call them as left and right. Yeah. So initialize left to 0. And what about right? See, in this case, we don't know the size of the array, right? So we have only the array list. What I should do here? Yeah. So length of array of -1. So because I need to find out the index of the last element, that is only possible based on how many elements are there in the list, correct? So -1 because starting from 0th index, right? So left is 0, right is, yeah, length -1. Or you can initialize both of them on the same line. Left comma right equal to 0 comma length of array -1. So Python supports this multiple assignment, right? So we can do it on the same line. Then what next? What is the main logic? Until you are within the range of left to right, what is the procedure? We have to find out mid element, correct? So tell me next what we have to do. We have to traverse from left to right, and we have to keep on dividing the no, array and find the mid element, and we check if the array of mid equal to key, correct? So if the array of mid equal to key, we will print that itself as the index position, or else we have to alter the left and right position. That is the main logic, right? So altering the left and right depends on whether the key is less than the array of mid or greater than the array of mid. Based on those two conditions, we will be traversing the left and right. So what is the first condition? You need to traverse the list. So I'm going to use while loop while left is less than equal to right. So initially this condition will be true, correct? So we have to traverse left to right. So initially left is 0, right is, for example, say 10. The condition will be true. Then what you have to do? Find the mid element. So how will you find the mid element? Left plus right, left plus right by 2, correct? So you will be taking the index positions of left and right and divide by 2. Then what next? We will check if array of mid is equal to key, correct or not? So if array of mid equal to key, so see, we have to return the value. So function says we have to return the value. So suppose if we find the key value at the place of array of mid, what we have to do? Yeah, division by 2, because we need to get the integer value. So we have to use 2 backslashes. So if array of mid equal to key, what we have to do? We have to return. What we have to return? Mid. So mid element we have to return, correct? Then if this condition is false, we have to go for else if. So ELIF I am using. What if the array of mid is less than key? Tell me what is the condition. If array of mid is less than key, suppose you can take the input as 2, 5, 3, 6, 3, 6, 7. So 0, 0, 1, 2, 3, 4. So 0 plus 4 by 2 is 2. So we get the mid element as 3, right? So what is our array of mid? 3. Suppose assume that our key is 6, right? I want to find out 6. So 3 is equal to 6. So obviously the condition is false. So then we have to check if array of mid is less than key. So obviously array of mid is 3 and key is 6, so condition is true. So which pointer we have to modify here, which index we have to modify, and what is the value that we have to update to. So obviously you have to keep on looking for left to right. So obviously in this case, we couldn't find the exact key, and we are getting the some kind of hint that since it is less than 6, obviously we have to modify our search only towards the right side of the mid. That means the greater element. Obviously left side all the elements will be okay. In this case I have to take the sorted, right? So assume this is 3, this is 3, and this is 5, correct? So 5 is less than 6, condition is not true. So array of mid is less than key, this condition is true. What is the pointer we have to modify? Initially our left was pointing to 0, right? Now we have to alter this position of left to mid plus 1. That means we have to directly jump to this point. So how to do that? So initially left value is 0. Now left value should be updated to mid plus 1. So this is our mid index is 2. Now it has to be updated to 3, so that we are continuing our searching from this particular position onwards, right? So what is the statement we have to write? So left equal to mid plus 1. So why we have to do this? Because since we couldn't find the element, we are sure that it is going to be found under the right side of the key. That is, it is the greater than the key. Then if the array of mid is less than key is false, then finally you can go for else. Here we have to update right pointer. Right pointer equal to mid minus 1. The same thing, obviously, in the case of if the array of key itself is greater than array of mid itself is greater than the key means, so obviously it is maybe the key value is lesser than the mid element. So we have to modify our search only towards the left side of the array, correct? So these are the three conditions that you have to update based on the mid value, right? Then suppose if all this suppose if you couldn't find this mid itself and you tried all the possibilities, then once the loop is over, what you have to do? You have to return -1. Correct. -1 indicates that element is not at all found in any part of the array, left or right. So -1 indicates the element could not be found. Okay. So now what is the action we have to take here based on the return value? We need to print. Suppose I want to print the index only, right? So what is the result value we got? Based on that, we have to take the decision. So if result is not equal to -1, correct? So if the result is equal to -1, what does it mean? Obviously, the key is not found. If the result is not equal to -1 means if the key is found in the some part of the index, right? So what we have to print? The key is found at position. The key is found at position or index, you can say. The key is found at index. So where is my key answer? In RES, correct? So in RES, we have the value, not mid, because we are returning the mid here from the function that will be stored in RES, right? So we have to print RES. Then if this is not true, then you can say key not found. Okay. So let's try this. So obviously you need to enter the sorted array. So now we are getting the answer as key is found at index 3. Actually it is 4, right? So what you can do, you can just make result plus 1 so that you will get exact index starting from 1. Okay, now we are getting key is found at index 4. So 90 is found at position 4. The result plus 1, you can do it here. Don't do it here. If you do it here, it will be again, you'll get a wrong answer. So you can make the mid plus 1 or result plus 1 in this case. I mean, while printing the answer, you can make it. So while you are iterating, you don't modify the mid value. Okay. So here, suppose take some longer array. Two, three, four, five, six. 2, 3, 4, 5, 6, 7, 8. Okay. So assume that I want to find 4. Tell me what could be the index position you will get. Try to trace it. If my key value is 4, because there are, okay, obviously this is not sorted. Sorry, it is not sorted, right? So you have to give the sorted array. So 1, 3, or 3, 2, 1, 2, 2, 3, 4, 4, 8. Okay, right. So what is the key index you will get? Now suppose I'm looking for 4. Will we get 5 or 6? So 1, 2, 3, 4, 5, 6. Why we are getting 6? Suppose this, if this is the case with linear search, maybe would have got this one if we are going from like zeroth index, and if we are coming from the right side, last occurrence means we would have got 6. But in binary search, that condition cannot be applied because we are segregating from the mid position, right? So based on the mid position only, we are going to get the uh, the index value. So obviously, this depends on the how the array elements are given. So 7 means 0 plus 6 by 2. So that means 3. So we are going to start from third index. So 0, 1, 2, 3, right? We are going to check from this position. So 3 is less than 4. So we are shifting our search operation from this position only, right? So 4, 4, 8. So again, from here, again, what we do, our low value gets updated to this position, high value remains same. So what will be our updated low value? 0, 1, 2, 3, 4. So 4 plus 6 by 2. That is 10 by 2. 10 by 2 is 5. So now we are checking if array of mid equal to 4. Right. So 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. So that means we are checking this one. Correct. So actually, though there is already 4 is occurring previously, based on the mid position, we are checking with the last occurrence here, right? So here 4 is found, then we are printing that particular index plus 1 we are doing because starting from first index, right? So 1, 2, 3, 4. So this is you should not confuse with the linear search and binary search, especially when you are having duplicated element. So which index is returned depends on the mid position. So either first or last, that doesn't matter. Mid is at index 5. Yeah, mid is at index 5, 0, 1, 2, 3, 4, 5. But we are getting 6 because we have to start from the index 1, right? So result plus 1 I am doing. So that's why output is coming as 6. So actual answer is 5. If even if you take 5 also, this 4 is at the position 4th index. This is in the 5th index. So you should not get confused why I'm not getting 4th index instead of why I'm not getting 4th index instead of 5th index. Correct. So this depends on the mid position. Okay. Mid equal to left plus. Say right, Vijay, we have taken right as length of array minus 1. So obviously, it depends on 0, 1, 2, 3, 4. So 4 plus 6 by 2. 4 plus 6 by 2, not 5 plus 7 by 2. So 4 plus 6 by 2. Here we are doing plus 1. That's why you're getting 6 as the answer. See, if it is confusing, you can just print as it is. You'll get same answer 1 double 2 4 8. Okay, I need to enter one more value. So we are getting 5 in this case, right? So this is our basic general approach. Now I want to give you one task which you can try it again. Binary search. Now assume, suppose in this case only, so let's take some bigger size. 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10. Okay, so in this case, you see what is happening. Or you can take all the same elements. Okay, let me simplify it. Let us take the elements as all 12s. 1, 2, 3, 4, 5, 6. Okay, now you see when there is a single element which is like repeated, though it is also sorted only, right? It is sorted in the ascending order. What is the key I'm getting? The key is found at index 2. Now, in this case, the output should not be 2. I want the output as what? Tell me. I want to find the index of last occurrence of the key. Last occurrence is when that is n, right? So that means 1, 2, 3, 4, 5, 6. I have to get the output as 6 here. So what modification you can do onto this existing code and get the corresponding output? You can try it. This is like both these approaches. Already linear search, I asked you to do it. Similarly, you can try to do it for binary search. So hope you understood the requirement. So what we did here is whenever we found the key, we stopped the searching, right? So matlab here we found the key, array of mid equal to key, we are returning from that position, correct? We are not continuing. Return means like the loop is stopping, but you should not stop it at this point. You have to keep searching as long as you reach the end of the array, correct? So though it is not necessary, I mean, obviously you're wasting time by iterating again, even though the key is found, but the question requirement is different. So here your number of iterations, how much time you're taking doesn't matter, because the question itself says you have to find out the last occurrence. So efficiency doesn't matter here. So in this case, here only you found the key, but what I want is I have to find the key which is appearing in the last. Correct. So in this case, what happened? Array of mid equal to key means 0 plus 5 by 2 is 2, right? So 0, 1, 2. So here itself you are getting the key, right? So that's why you're getting the answer as 2. So you are not continuing. So what is the modification you can do in the code? You can try. So no need to send to me. Everyone should try. So others you can try it. Whatever I'm going to, yeah, no need to send me. Let others try. Okay. So Suriteja, Manoj, whoever is trying, Vijay. So you guys can do it for yourself. Let others try. Let them think logically. What are the modifications they have to do? Don't no need to send to me in the chat box, right? Because all these questions, whatever I'm going to, uh, or the different ways of doing the same logics, by applying certain changes based on the requirement, you need to know. And some of these questions I'm going to give in your assessment also, based on like how many of you attended the session, it will be beneficial. So it is like those who are attending, they'll get to know how to do it. Okay. So find the index of last occurrence of the key. So you need to modify only certain things here, not like everything. Certain changes you have to do in the same code, and based on that change, you have to print the last occurrence. Is that clear? You understood the requirement, right, everyone? Okay, so you can try this also. Find the okay. So before going to the next topic, I need to tell you one important topic which I like. Maybe I would have taught. I don't know. Just it's like a revision. If you know, it's fine. If you don't know, you just need to remember this thing. Okay. So suppose assume you have some function called as arithmetic, right? So arithmetic which accepts some two variables a and b, right? So say for example in this function, I'm going to do some result, right? So suppose addition, add one equal to a plus b, then multiplication, multiplication equal to a into b, then subtraction equal to can use absolute of a minus b, right? So three values I'm computing in this function. Then once it is done, return add comma, multiply comma, sub. So can we write the statement like this in any other language or like in C? Since you're learning C, can we write return multiple values like this in C language? Okay. So you know this is not supported in C language, right? So let's try to do it in Python whether it supports or not. So then let's read two numbers a comma b on the same line. Tell me how to read two numbers on the same line, integer numbers. Can I write just input dot split? Obviously, if I write input dot split, they will be considered as a string. So what I should do? Tell me. A comma b equal to, yeah, so very good. So map of int comma input dot split. So these two will be read in the format of integers in the same line. Then we will call this function. What is this function? Arithmetic. Say like result equal to arithmetic, and we'll pass these two values. Right. Then we'll see whether this works or not. So I'm trying to print that result. Okay. So let's enter two numbers. Is it working? So, okay, you can take some small numbers, 10 and 5, right? So 10 plus 5 is 15, 10 into 5 is 50, 10 minus 5 is 5. So this is the important advantage in Python, right? So in Python, we can return multiple values from the function, right? I think I missed this important point. We can return multiple values from the function, and in what format they will be written? Values will be returned as tuple, as a single tuple, right? So though you are returning the three values separately, you need to return them. I mean, the compiler will return them as a tuple, single tuple, right? Now tell me, can we segregate again into different variables? Now in this case, they are printing as a single value. So how can we differentiate them? For example, I'll take again same variable. I can take like here add multiply and subtraction. Same variable I'm using. So here I can print them separately. Okay, so this will also work. So again, this is unpacking we are doing. If you want to store all of them into one variable, you can do it, not an issue. But in this case, whatever the value I'm returning, in the same order, I am extracting and storing. But what will happen if I change the order? Like, like for example, I mean, whatever the order you are sending, in that order only value will be stored. I mean, for example, here MUL, then I will send sub, then I will send add. So now you can see what is the first value that is returning MUL, that will be stored in this add variable. Then this sub will be stored in this mul variable. Then again, this add will be stored in this sub variable. Okay. So that's why we are getting for MUL, we are getting the output as 50. Then for like multiplication, we're getting it as 5 because we are returning sub here. Then for add, we are getting it as like here we are getting 15, though the variable name is different. So what you need to be careful in whatever the order you are returning, you should declare the variable in the same order so that you won't have any confusion in the output printing. Or if you want to print it them as a single value, you can just declare a single variable and it will be considered as a tuple. So this is an important point. So those who didn't know, please note it down. Those who knew, no problem. So why I have told this one is you might be needing this for like the questions that I'm going to give in the coming days, right? So what I want is suppose in this case, I might want two, three values to be written. For example, here you are returning binary search, mid position you are returning. Okay. So along with this, I also want you guys to return one more thing. For example, return mid, comma, then what you have to return? Array of mid. Correct. So I am returning two values. Return mid, comma, array of mid. Both values I am returning. In this case, return -1. So now, for example, what is the modification you have to do here? Accordingly, you can take the decision. So here you can also see when you are returning two values, even for not found also you have to have the two values. Return -1, comma, -1. That means, or you can say return -1, comma, what you can do, you can return none. Correct. None means element is not there. So -1 indicates the index position, whereas none indicates that element is not there. So now you can have those variables stored here, result. So what is the output I'm getting? The key is found at index 3, comma 4. So what is this 3? Here what I have to do? What is the modification I have to do? So it is returning 3, comma 4, right? So what is 3? 3 is the position where we found it. So 0, 1, 2, 3, and value is 4. Yeah. So how can I print only element or index here? Suppose here I'm printing both, right? I'm printing it as a complete tuple. So I don't want to print it as a tuple. I have to only access the index separately, or say, for example, element separately. How can I modify it? The result of one. Okay. So result of one, if I say, what will happen, you will see. Okay. So the key is found at index 4. Correct. So here you can access it based on the requirement, or else you can create a separate variable and access them. So result of one is going to give me the value, correct? Whereas the result of 0 will give me the index. Okay, so the key is found at the index 3, right? So what if the key is not at all found? Yeah, so this one you need to tackle. In this case, it is not going to else, right? So I want to go for else. What is the modification of? So instead of checking if the result is not equal to -1, what you have to check? Obviously, it is returning some value. So if return is -1 or none. Yeah. So here, what is the corresponding modification you have to do is if a result of 0 is not equal to -1, then you can do this. Else, okay. So no need to manually check again if result of 1 equal to none. Just you need to modify this. Obviously, if this is false, it will go to here. So accordingly, you need to take the decision. So this is the important difference I wanted you guys to learn how to return multiple values from the function. So hope you guys understood. So whenever if there is a question where like if I had mentioned you should return multiple values or based on see what you are printing, I don't know. Sometimes I would have mentioned, sometimes I may not have mentioned. If I had mentioned the based on the condition printing, like based on the string, what is the output you are printing. If the key is found, what you have to print. If the key is not found, what you have to print. Especially for sorting, this is mandatory. I will next to when we start sorting, I will tell you how to use this multiple return values and accordingly you can modify the code, whatever you are learning. Okay, so this is one of the thing you need to notice, like how to return multiple values. So most like this is very important updation in Python, which was not there. See, I always felt in C this is a problematic because at a time we can only return one value, but that problem has been overcome by the Python with this multiple return values as a tuple. Okay, so that's why tuple is very useful in certain cases where like these kind of applications are required. Such cases, tuple will be used for the return value. Okay. So next we will see sorting techniques. So this much is more than enough. In most of the product batch exam, they have given binary search. Binary search like with this kind of modification, they would have given either normal order of searching or like find the index of last occurrence. Any one of the approach they will ask. So you should be able to implement this on any given day because if you have learned basic well, I think this is not that difficult to implement in the exam, right? So in your product batch exam, you can just all the types of searching, sorting techniques, just revise, and along with that, you can just stack and queue implementation, basic implementation, and I think on one or two exam they asked about traversal of the tree. Generally, they won't ask, but that should not be a problem. Most of the students won't attempt that question because there will be around 7 to 8 questions. So even if you skip that tree question also, you have a very good chance to qualify. Generally, out of 8 questions, if you are able to solve minimum 3 to 4, like four, you can take it. 4 questions, if you are able to do it, then you have a good chance of getting into product batch. But less than three, then there is very less chance. So make sure like you are going to solve at least 4 questions in any of the exams that you are going to attend in coming days, right? So especially sorting and searching techniques, I am already telling you 1 question based on sorting, 1 question based on searching, or like basics of stack queue and tree traversal. You might get this uh, applications, or like for say how to create a basic simple linked list also once they have asked. But up to stack and queue, if you were able to do it, then that would be more than enough. Okay, so let's see the first technique, bubble sort, which is like most widely used for teaching only. In real time, they don't use this. Okay, so because as we already know, bubble sort is just for like understanding how the sorting works. In reality, the bubble sort is very rarely used because it is like time complexity is very huge. So before I uh, go for this sorting techniques, you should know the flow chart. I will just give you one flow chart. Okay, so everyone should remember this flow chart. Okay, this is like going to help you a lot in your interviews or like in any kind of preparation. So sorting algorithms, look, we have so many sortings, right? We need not to know everything as of now. Quick sort you might have learned, merge sort you might have learned, bubble sort, insertion, selection, right? So these are the five important sortings you should know. Remaining all you can just ignore as of now. Heap sort also, I think it's there in your syllabus. You can just go, but heap sort they hardly ask. But most basic sorting that every student should know is these five: quick sort, merge sort, bubble, and insertion. So I'm going to ask you just like a oral question based on this flow chart. Can you tell me, considering all the type of cases, best, average, and worst, what is the most preferable sorting technique from the one which I have highlighted? Forget about others. Whatever the sorting techniques I have highlighted, which one you feel is more best one in terms of all the cases, not only best case, average case, and worst case in general? So I think I hope I need not to tell you what are this best, average, and worst notations. You might have already learned this in your academic syllabus, right? So what does this omega indicates? It's a best case, right? On any given day, that is the best performance it can give in terms of execution time. Worst case means basically like depends on the length of the array and how long it can take to sort it, right? So that is basically worst case. Average means like neither here nor there, in between. So based on these five sorting techniques, what is the uh, sorting techniques that you feel is like most preferable considering all the values? No answer. No answer. Nobody knows which is the best sorting technique. As per the chart here, we can observe the values and come to a decision which is the best sorting technique. This is one of the very important interview questions. Like you should know this. Any answer would be fine. Like even if it is wrong, no problem. You can come up with your own analysis and you can just say. Strange that no. Okay, merge sort, heap sort. That's why I didn't highlight heap sort. Among the given sorting, what one is best? Okay, I think I got the response late. Yeah. Okay, so if you observe this chart, you can come to a conclusion. If your priority is time complexity, then obviously you can come to the conclusion that merge sort is most preferable, because that is taking common value for all the type of cases, right? In login, if your time complexity is the more priority, if your space complexity is more preferable, means again merge sort is not going to be more effective, quick sort is going to be more effective. Correct. So here the problem is merge sort, the procedure, it divides the array into multiple subarrays, then sort them and again merge them together. So it is going to consume some extra memory space to do that. Whereas quicksort doesn't take any extra memory, right, to do that work. Similarly, if you see among the space complexity, we can say both bubble, insertion, selection, all of them are feasible, because they take O of one constant space, where they don't require any extra space to do the task. Whereas quicksort takes log n, right? But in general, quicksort is widely used uh, because of the fast processing of the input, and also the approach. So approach is, we call it as a two pointer approach, because you are using two indexes I and j, and you are traversing both from left and right, and comes to the conclusion where exactly we have to do the partition and then continue with the sorting. So two indexes are moving simultaneously, so you are going to complete the iteration faster. Correct. So that's why quicksort is widely used. But quicksort has its own disadvantage, because it takes O of n square in the worst case. Worst case means, what is the answer? Anyone knows? Suppose if the array is already sorted, quicksort unnecessarily loops for n square times. So this is also very important question. You have to justify why it is O of n square in worst case. You have to trace it and explain if they ask, right? So this is also important. But in general, if anyone asks you, you can just go for quicksort if the like time worst case is not the problematic. But in general, merge sort going to be the more effective in time complexity. If in terms of space complexity, you can prefer this selection insertion over quick sort and merge sort, right? Again, among these three, bubble and insertion are going to perform better in the best case, whereas selection takes n square time. So you should always remember these values before attending any interviews, because they will definitely inquire about your knowledge on this, right? What do you mean by time and space? So do anyone knows the terms called as in place algorithm and stable algorithm? What do you mean by in place and stable? Any idea? Okay, so if you see this diagram, you can just understand what do you mean by stable and unstable. Yeah, this is a very important terminology. Stable and unstable sorting. Just observe the input. This is your input 3, 5, 2, 1, 5, 10, and this is your output 1, 2, 3, 5, 5, 10. But they are telling this is stable, this one is stable, and this one is unstable. So if you carefully observe, what is the problem here? Both are sorted, right? Both are sorted. All the sorted arrays are not stable. Okay. Even this is also sorted and this is also sorted. But why we are calling this as unstable? You just observe the circleized numbers, what is happening there. There are two files, right? This is first file, this is second file. In its original array, this 5 is coming in the second index and this 5 is coming in the fifth index, correct? So 2 and 5. After sorting, whatever the first 5 in the order of the insertion, this is coming first here and this is coming next. That means it is relative to the order of their insertion. That means their positions are not changed here and there. That means in this case, you see, this 5 came first and the first 5 went next. Correct. So this is unstable because though they are already in the sorted position, you have unnecessarily exchanged their positions. Exchanging means you have unnecessarily wasted by changing their positions and took some extra time to do that. So this is called as unstable sorting. So you are already sorting, but unnecessarily wasting some extra iterations on these kind of inputs. So what are the algorithms that you need to which algorithms are sorted, which algorithms are stable, which algorithms are not stable. You should have a complete idea. Definitely, that will be an important question, right? So you understood what is the meaning? Order of the insertion should be maintained. If the elements are already in their position, correct position, you should not change their position, original position, and keep them intact in their output, final output sorted value also. If you are exchanging the values unnecessarily, then you are wasting some more time to do that, and that's why it is called as unstable. So that means it is not going to be more effective. Okay. Yeah. So yes, as Surya Teja is telling, second occurring is coming first and it's unstable. It's one of the important question, right? So when you say unstable, stable means what? Basically, order of insertion should be maintained for already sorted elements. That is the point. So these two are already sorted, 5 and 5, and they have to come in in their order of insertion. Then similarly, what is the in place? In place means which doesn't take extra memory space, which doesn't go out of the required memory based on N, right? That is in place. That means suppose if your array size is 1,000, within that 1,000 bytes only, you are going to do the sorting. You are not going to take any extra memory, right? So before I go for sorting, you can make a note of what are the stable algorithms. So stable sorting techniques. Right. So your insertion sort, if you learned insertion, merge, these are stable algorithms, right? Whereas your bubble sort, selection sort, and quick sort are unstable, right? So, right, so your insertion merge are stable, right? So whereas bubble sort, selection sort, and quick sorts are unstable algorithms. So that means these techniques will alter the positions unnecessarily, whereas insertion and merge keep their insertion order as it is, right? So similarly, in place, if you talk, in place algorithms, right? So what are the in place algorithms means your bubble sort, your insertion, selection, as well as your quick sort. So these are in place algorithms, right? And your merge sort is not in place. Only merge sort is not in place. Rest all are in place. Why merge sort is not in place? Can anyone tell me? Sort is place. The remaining all are in place except merge sort. because the merge sort has to divide the array, again recursively call them one by one, and again after sorting they have to combine. So obviously you're going to take more time, more memory, apart from the required n to do that task. So that's why merge sort is only the in place. Rest all like this bubble, insertion, selection, quick are stable, I mean in place algorithms, right? So this is an important point you should know before doing any sorting techniques, because we have so many sortings. People will ask you, the first question itself is why you have learned so many sorting techniques. You could have learned any one of them, right? Because we have search, selection, bubble, insertion, quick merge, right? So many we have. So first question they will ask is, if you say I'm very good in sorting, the first question itself will be, okay, why you learned so many sorting techniques? What was the point? So you should be able to justify your answer in this way. So we have so many techniques based on the situation. We need to know what one to use. If there is a memory requirement, these are the certain sorting. If there is a time complexity requirement, these are the sorting techniques. If you talk about stable, I can use this. If you talk about in place, I can use this. So you should be able to justify your learning. If you keep simply learning without any idea, then that is not going to help you. So make sure that whatever you are learning, you should have some purpose behind it. Okay. So based on this, you can just take some sorting techniques, and remaining you can do it later. So first one and most widely used is like, I mean, again, for teaching purpose, not like in real time, bubble sort, right? So bubble sort, what is the technique behind bubble sort? You have to compare each element one by one, starting from the first, and if it is greater, you have to exchange their position. Then you have to go for the next iteration. So every element will compare with every other element. That is the bubble sort technique. Okay, so let's directly start implementing this. So let's take some function name as bubble underscore sort. So your input could be array name. Right. So obviously you need to find out, first thing is you should know how many elements are there in the array. So n equal to length of array. And then obviously you need to use for loop, right? So for I in a range of n, correct? Then for j in a range of, tell me what I should use here. So n minus I minus 1, right? See, if your input is like this, 1, 2, 3, okay, so 1, 3, 4, 2, 5. This is your input. You have to start I and j both from 0th position, correct? And you should always go up to n minus I minus 1. Why n minus I minus 1? See, after first iteration, what you will do, you will compare second element with first element. So in this case, array of j is not greater than 3, correct? So you will just keep on incrementing j value. Again, 1 is not greater than 4, 1 is not greater than 2, 1 is not greater than 5. So that means 1 is already in its correct position. So this is already in the sorted position. So when we go back to the main for loop, I value will be updated to 1, j value will be also updated to 1, but we are going only up to the term n minus I minus 1. So at this point, what is your I? So n value is 5, 5 minus I value is 1. So 5 minus 1 is 4, 4 minus 1 is 3. That means I'm going to iterate only up to third iteration, because this is already in the sorted position. So again, I need not to compare that. So to avoid unnecessary comparison of the already sorted element, we have to use n minus I minus 1, correct? So this is an important question. Why you have to use n minus I minus 1? So for every iteration, the element will get sorted into its correct position. Then for the next iteration, we have to skip that particular index and only go up to that previous index. So in this case, I have to go up to only third index. Similarly, once this 4 gets sorted into this correct position, next I value will become 2, correct? So n minus 2 minus 1. That is 5 minus 2 is 3, 3 minus 1 is 2. That means we'll only sort up to this point. So in that way, we are reducing the number of iterations and number of comparisons. So that's why in your for loop, for j in range 0 to n minus I minus 1. So you can just ignore this also. For your understanding, you can write. For I in range to n, for j in range of 0 to n minus I minus 1. Okay. Now what is the condition? If array of j is greater than array of j plus 1. Correct. We are checking first element with the next element, and if it is greater, we have to swap. If the first element is greater than the second element, we have to swap it. Right. So how will you do the swapping? Generally, how will you do the swapping? You will take some temp variable, right? So temp equal to array of j, something like this. Then array of j equal to array of j plus 1. Then tell me, array of j equal to 10. So this is what you do in C language, right? So this can be avoided in Python, and you can do it both on the same line without using the third variable. So Python supports this assignment, right? A comma B equal to B comma A. That means you can swap it on the same line just by exchanging the order of the variable. Okay. So you can write array of j comma array of j plus 1 equal to array of j plus 1 array of j. So what is the meaning here? So this value goes into this position, and this value goes into this position. So array of j plus 1 will get stored in array of j. Array of j will get stored in array of j plus 1. So you are swapping without using third variable in Python. Correct. So once this process is done, we'll come out of the all the loops. Right. So in the inside loop, outside loop, and we will return the sorted array. So you can, what is the value we are returning? The list. So in this case, the return value will be your list. See, we are not returning single element, we are returning the entire list. So return value will be list. Now for the input purpose, you can just directly read the elements. List of map of int comma input dot split. Okay. Then we can call this sorted bubble sort function to sort it with the input. Then you can print that result. Okay, so it is getting sorted. If I don't want this command, just right. So you can write star arrays to just print the space separated value. Now, is it most efficient? No, because it is going up to worst case law, it is going up to n square, right? So how much time it is taking? N square. So further, this can be improvised. Tell me, what is the improvised bubble sort? Or we call it as optimized bubble sort. So how can we further optimize it? Say, for example, if I give the input 1, 2, 3, 4, 5, it is already sorted, right? So unnecessarily we are doing this comparison. And in some test cases, they will always ask the passes, right? What is the output after each pass? So that is one thing you should know. So for example, after swapping, you need to print the pass, right? So here what you can do, print pass of, you can use the if string method. Okay, so if you take some other input after each swap, right? After each swap, you are getting pass values, right? So this is how you can do it. Pass, I mean, based on the what is the element that is changed. So initially it was 34216. After pass one, it got changed to 32416. So in that way, all the elements are sorted. Correct. So pass output, you can print it inside. Yeah, there is some changes here, right? Why it is coming duplicated? Can anyone tell me? How can we improvise that? So where this pass should be printed? Pass should be printed after swap or coming out of the swap, right? So I was trying to print here. So obviously, we are within first pass. There are a lot of changes are happening. So we should print after pass, first pass, what is the final output. So once I come out of that if condition, I have to print that, right? So I have to print that pass, not here, but here. Okay. After second for loop. Yeah, sorry, here. Yeah. So now you see what is the problem here? Though array is already sorted, you are getting unnecessary passes, correct? So you're getting unnecessary passes here. This can be avoided. So what we can do, we can do one thing like yeah, if number of swaps zero, so you can use some flag variable initially. Once you enter the inside for loop, you can use flag variable and you can initialize to zero. Flag is initially zero once I enter the inner for loop. So we will say whenever there is a swap, we will update that flag to one. See, when there is a swap means the array is not sorted, right? So whenever there is an array that is not sorted, obviously swap will occur, and at that moment we will update that flag to one. Then when we come out of that inner for loop, we will print if flag is one, then only we'll print the passes, right? That means there is a change, then only we have to print that pass, correct? Otherwise, if the flag is still zero, we will break the loop. So why we have to break the loop here? Can anyone tell me? After the first iteration, if the flag value is not at all updated, means obviously there is no swapping that happened. That means the array is like from the first iteration itself, the array is already in sorted order. So this will save a lot of time, correct? Colon is missing here. Suppose my input is 1, 2, 3, 4, 5. What is the output I'm getting? Just 1, 2, 3, 4, 5. So here I am getting the output as it is. Okay. So I'm not wasting unnecessary time on that. Suppose if I give my input is 1, 3, 2, 4, 5. So I'm only getting one pass, right? So again, we are not printing unnecessary passes. So only if there is a change in the swapping, I mean, if the elements are exchanged, then only we are printing this pass value, or else we are just exiting the loop. Yeah. Yeah, we can use else. Yeah, in this case, like else return you can use or directly return array you can use. Okay, so now I will give you one task which you can try it later on. You can apply this concept of multiple return value. So what I want you guys to print is you have to print obviously if the passes are there means you can print the passes, right? If the passes are not there, you can directly return the value. Two values you can return, right? Modify this code, modify the return values, what you are returning to return indication of like the sorted array, and if the array is already sorted before sorting. Okay, before sorting. So instead of just printing this 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5 means it is printing 1, 2, 3, 4, 5. So I don't want to print 1, 2, 3, 4, 5. I want to return one more variable along with that array. Say for example, flag 2. So this flag 2 should do what? It should check if there is no swapping. So then while printing, we have to check if there is flag 2, right? The flag 2 value is updated. Then we have to print there is there is nothing to print, or else you have to print the sorted array, right? So that changes you can modify here. You understood, right? What is that requirement I'm asking? You can either print if the array is already sorted, no need to sort, it should be the message. If the array is not yet sorted, then you can print the sorted output. Two values you have to return here. One is the sorted array and another one is the indication for whether the array is already sorted before sorting. So you can use this concept of multiple variable returning and apply how to do it on this bubble sort question. So this is the optimized one, which will take very efficient time compared to the basic one. So it can be further improvised to login of login, right? So this is called as optimized bubble sort. So similarly, you can try to implement two more programs I am going to add today. So insertion sort and selection sort. Okay, so as you guys already learned them, you can just practice this too. The model I will add these questions. So just before, yeah. So what is the logic of your insertion sort? Can anyone tell me based on this diagram? So what is the logic here? So you will initially assume that the first element itself is the smallest element. Then we compare that first element with the all the remaining elements in the array to find out the next smallest element in the array, right? Then if we find out the next smallest element in the array, we exchange that with the first element, right? We alter the position of that element and bring it at the position before the first element, right? So basically that's why the name is insertion sort. So we are going to insert each element at their respective positions, right? So this is the technique. So obviously you need to take the initial value of a minimum element as array of 0, then compare all the elements and update the minimum index, then exchange that minimum index with array of 0, right? Then once the loop is over, what is the next thing that you have to do? Whatever the index that you applied, that the key value which you assume that as a minimum value 85 should be going to the next position. So suppose if key equal to a of I, then a of I plus 1 equal to key you have to write. That means it should go to the next position, right? So if key is in the 0th position, it should be going to the first position after updating this 12 to its respective position. That is the insertion sort logic. So you just go through this insertion sort and apply the logic. So your for loop should start from 0 or 1. By the diagram itself, you can tell me. While comparing the elements, your for loop should start from 0 or 1. Yeah. So obviously, when you assuming that the 0th index is the initial smallest element, obviously you have to start from 1, then compare as long as, see, suppose, assume that this 12 is here, right? You have to replace and you have to bring this 12 into this position, means there should be somebody who is keeping track of this index, right? So you have to go in the reverse direction, means you have to do some minus j minus 1 or I minus 1 you have to do. As long as there are elements greater than 0 and the key is less than the previous element, you have to keep on changing their position by doing the j minus minus. So once that condition becomes false, this have to go to their corresponding position. So you're just moving them one step, below. That is the insertion sort logic, right? So similarly, so we have selection sort, right? So now tell me what is the logic could be for the selection sort based on the diagram. Is it similar to insertion or is there any change? If you see the diagram, it looks probably like same, right? Placing smaller indexes. You have done the same thing with the insertion, right? So both the approaches are pretty much similar, but here you are assuming through the index position, not based on the value. Whereas insertion, we are considering the value reference. Here we are considering the index reference. So say for example, we will assume the first 0th index as the smallest element, right? Then we compare all the next elements with the 0th index, right? So we assume that this is the minimum index element. Then we compare it. Suppose if you find out, suppose say 13 we found, and once we found the 13, we will update that minimum index value to 13th index. Suppose after 13, if you find somewhere 12 here, we will update that minimum index value to this position. Correct. So we keep on finding the minimum index position, and once the loop is reached the dead end, what we do, whatever the index position we got, the minimum index position, that we will exchange with the first element. So in this case, 13 was the minimum index value that we got, and then we are exchanging with the first element. So 13 and 29 were exchanged. Then we will continue with the loop. I gets updated to 1. Now we will assume that this is our minimum index, correct? Then we will compare, because 13 is already sorted. We should not assume starting value is the minimum index, right? The next value we are assuming that's the minimum index. Then we compare again in a similar way, find out the next minimum in the given remaining list of elements. Then wherever we find it, we keep exchanging that. So this is an important difference. If you don't get confused, in the insertion sort, we are assuming the first element as the minimum, right? Then that one we are comparing with all the previous element. If it is less, we will exchange it, or else, or you can say in reverse. Here we are checking for the greater, but you can start from like 12 and you can check if 12 is less than 85, then you can exchange, right? So in that way, we are going to modify both the logic insertion and selection. That's why both of them are very similar. So any one approach you can like know in detail, that will be fine. So in this case, like basically what is the logic is like you are assuming key equal to array of 5. That is like the first element you are assuming it as a key. But here like they have assumed 85 is a sorted list. So any one approach is fine. So like what I always do is like I will assume this is the key and I compare with the previous element. So in this case, if the right see key is 12 and J is, I mean that J index is 85. So key is less than 85, condition is true. So we exchange this 12 and 85 and J becomes minus 1. That means it becomes minus 1. So we will stop the iteration and go back to the main for loop. Then again we update, then we compare, start from this particular index 59. So 59 will be compared with 85. 45 will be compared with these two values. So in that way we can iterate. So both the approaches are similar only, but here we are concentrating on the index position. Here we are concentrating on the elements. right? So try to do this two logics. If you couldn't understand, we will do it in the next session. So next session, I will be very important sorting, quick sort. So there are multiple approaches in Python for quick sort. So don't miss the next session. So we'll do quick sort, merge sort, and stack queues, right? So stack and queues. These are the next session topics which we're going to do. But I will add the question if you are able to do it. Try to do quick sort technique also in the Moodle, right? But there are multiple approaches which you need to know in Python for quick sort as well as merge sort. Stack and queue, I'll just inbuilt approach and how to create our own model as stack and queue, which we can do it like based on our C language, how we have done, we can do it similarly in Python also. Along with that, there are some inbuilt models called as DQ, right? So you can use DQ to implement stack and queue both. So the model name is DQ. So both approaches I will give you in the next session. Okay. So we will see you again on Wednesday, not Wednesday, Thursday, right? So all these programs I am going to give the last date is 30. Okay. I don't want any further extension. So 30 will be your last date, Sunday, so that you get some 2 days revision time for preparing for your assignment, final assessment. Okay. So those who are attending session, you can just practice all searching techniques. Definitely, you will be having 1 or 2 questions based on sorting and searching. Whatever I mentioned, starting from bubble to merge sort, stack and queues. So to practice next, whatever the questions that I'm going to add in the model, definitely that will help you in your final assessment. Okay. Yeah. Definitely, I'll extend the regular expression module until tomorrow. Until tomorrow night, I will extend. Okay. So see you in the next session. Thank you.